For hundreds of thousands of years, early human survival relied entirely on physical strength. Their primary hardware consisted of massive, heavy stone tools that required immense brute force to swing and strike. Carrying that heavy hardware across long distances was exhausting work. It slowed down hunting parties, drained their daily energy reserves, and strictly limited how far a tribe could migrate. Human progress had hit a physical bottleneck. To move faster and hunt smarter, early humans had to rethink their engineering and transition from raw brute force to precision tools. That technological pivot arrived during the Mesolithic Age, roughly between 9,000 and 4,000 BC. Instead of heavy boulders, early engineers began designing specialized stone tools, barely 1 to 5 centimeters in length. We first uncovered the exact scale of this invention in 1867, when archaeologist A.C.L. Carlleyle unearthed a collection of these tiny artifacts in the Vindhya region of India. Scholar Hodder Michael Westrop officially classified these microscopic artifacts as microliths, which are also referred to in Hindi as Sukshma Pashan Upakaran. But it is difficult to see how a stone the size of a fingernail could take down massive prey, or provide enough of an advantage to let a tribe stop following the herd and start building a settlement. You cannot carve a microlith out of standard sandstone or limestone. It would simply shatter on impact. To hold a microscopic edge, early humans had to source entirely new, highly brittle rocks. They utilized materials like agate. Its smooth, waxy surface made it predictable, allowing ancient toolmakers to chip precise flakes without the rock crumbling. They also gathered chalcedony, a highly durable mineral with a dense, crystalline core capable of withstanding immense pressure. For elite cutting performance, they sought out carnelian and jasper. These sharp, reddish stones could fracture into geometric lines and hold a razor-sharp edge over long periods of heavy use. Instead of scavenging opportunistic rocks, Mesolithic humans acted as intentional material scientists. They sourced specific minerals to meet strict engineering tolerances. To shape these incredibly hard stones, they developed the fluting technique, or Nali Alankaran. They applied targeted downward pressure to the top ridge of a central stone block, known as a core. That specific pressure forced long, thin, uniform flakes to peel off the sides, leaving a grooved, fluted core behind. Then came the crucial final step of blunting. The engineer would intentionally dull or flatten one specific side of that sharp flake so it could be safely mounted. This exact process allowed a single stoneworker to produce dozens of identical, interchangeable components from a single rock. It meant tool repair was now a matter of simple replacement rather than starting from scratch. Using this technique, they created distinct geometric shapes. Single-edged blades were elongated and engineered entirely for clean slicing. Lunates were shaped like tiny crescent moons. When lined up in a tight row, they created a highly effective serrated edge. Needle-like points were carved to pierce thick hides, while trapeze shapes provided the perfect aerodynamic balance for arrowheads. They also crafted scrapers and burins, specialized tools dedicated to cleaning skins and carving intricate, deep grooves into wood. This resulting collection formed a comprehensive modular toolkit. These specialized geometries multiplied exactly what human hands could achieve in the wild. A moment of wonder. Despite their precision, microliths were actually useless on their own. They were never meant to be held by a human hand. They were designed as components for composite tools. These tiny stones were slotted perfectly into grooves carved along bone or wood handles, locked firmly into place using natural tree resins and glues. This provided a massive engineering advantage. If a single stone tooth broke during a hunt, you didn't have to discard the entire handle. You simply popped out the broken flake and glued in a new one. By successfully separating a weapon's handle from its lethal cutting edge, early humans solved the physical weight problem that had restricted their hunting efficiency for millennia. This lighter composite technology led directly to the bow and arrow. Hunters could now travel unburdened, move faster through dense environments, and strike their prey from a safe distance. And when those same serrated teeth were set into a curved wooden handle, humans had engineered the sickle, allowing them to transition from nomadic foraging to the organized harvesting of wild grains. By lifting the physical burden of heavy stone tools, these tiny blades provided the mobility and precision that allowed humans to settle the land. If you found this breakdown of ancient engineering helpful, please like this video, share it with your friends, and subscribe to the channel. Let us know in the comments what ancient technology we should cover next.